In this video, I will be demonstrating how to do problem 10.20 from Interactive Statistics. And this is an example that's similar to one of the problems on the final exam. So in this problem, we're talking about cuckoo eggs. A study by E.B. Chance in 1940 called The Truth About the Cuckoo demonstrated that cuckoos return year after year to the same territory and lay their eggs in the nests of a particular host species. The eggs are then adopted and hatched by the host birds. The ordered data are provided in lengths in millimeters of cuckoo eggs found in the nests of meadow pipit birds. So the first thing we're asked to do here is summarize the data both numerically and graphically. In particular, comment on whether a normal model for egg length is plausible. So it's interesting, the book specifies parenthetically that the data are ordered. And the reason for this really is to facilitate finding the median by hand, which is the 50th percentile. But in this class, we're using the calculator to do all of these computations. So now notice, whoops. Notice I've already entered the data into a list on the calculator, and I've named the list. I'm calling it cuckoo. So the first step to do this problem on the calculator would be to enter the data, and I'm not going to cover that in this video. I named a list. You could also enter the data into one of the built-in lists, L1, L2 through L6. So summarizing the data, the first thing, what that really means, summarizing the data numerically, is we're looking for the sample mean, we're looking for the sample standard deviation, we're looking for the median, we're looking for the interquartile range. I'm not going to go through all of that because this problem isn't really about necessarily summarizing the data graphically. Part B is where we're really heading, which is to create or construct a 95% confidence interval. And keep in mind, one of the assumptions for using a normal distribution to create such a confidence interval, or a t-distribution, in this case, we'll talk about that when we get to part B, is the assumption in normality. And so really the main purpose here, I think, is to look at whether or not the mean, the sample mean and the sample median are about the same number. Because remember, if the distribution is skewed one way or another, the sample mean will also be skewed. The median is always the middle number. So if we have a normally distributed population, we would expect the sample mean and the sample median to be really close or not too far away. So this is the first thing I'm going to do. On the calculator, to summarize the data numerically, what we do is we use something called 1var stats. And to find this command on the calculator, just press stat and then scroll to calculate, calc, and choose number 1. And the first thing we're asked for here is the list that we'd like to find the 1var statistics for. So I'm going to go to my list of lists, choose the name of the list for this particular data set. There's also an option here for a frequency list. In this example, we don't. That's not applicable, so we would just leave that blank and then choose calculate. And notice we have the sample mean. It's about 22.3. Sample standard deviation, and when we were covering this originally, in Chapter 5, we were looking, I explained in one of those videos that the S here means sample standard deviation and the sigma means population standard deviation. So the sample standard deviation is about 0.92. And what we're really interested in here is the median. So we've got the median is about 22.25. The mean is about 22.29. So those are very close together, which indicates that there's no evidence here that the distribution would be skewed. The other thing that we want to look at, though, are the graphical summaries or the graphical information that we can use. And there are two types of plots that we look at to determine normality. One is a histogram. So I'm going to go ahead and draw a histogram. And notice I press second function and then y equals to go to the stat plot menu. Then I'll choose number one. I want to have it turned on. And then I come down and I pick the icon for histogram. And then I need to paste in the list name. So second stat. I'm going to take a shortcut. You can just press the number 7 here, or I can. And now in this particular example, I'm not really worried too much about drawing this or printing this histogram out or anything like that. I'm just looking at it to get a sense for what the shape is. So I'm going to do a zoom and then zoom stat, which is choice number 9. And the calculator will automatically set up a coordinate system that the histogram will fit into. And because the main thing I'm looking at here is to see if there's any skewedness to this distribution. And this is looking really symmetric. So there's no evidence here that this data came from a non-normal distribution. The other type of plot we use to check normality is called a normal quantile plot or a QQ plot. So I'm going to go back into the stat plot menu and change the stat plot type to the QQ type, which is this last icon right here. So I select that. I need to rescale the axis, so I'm going to do another zoom stat. Now when we're looking at the normal quantile plot, what we're looking for is a really fairly linear looking scatter plot. And this one's pretty good. I mean, when you're dealing with a skewed distribution, this will really be exaggerated. A lot of times it'll look kind of like this real exaggerated kind of a curvature. And so again, I'm not seeing any evidence here that the assumption of a normal model for egg length it seems plausible. So everything's adding up. Now the other thing about the data here is that let me go back to the one bar stats for a minute here and look at that output one more time, because I want to key on this sample size. So in chapter 10, which is the chapter this example comes from, it's a discussion of when using the normal distribution is appropriate and when using the student t distribution is appropriate. And one of the key issues is with sample size. And the criteria or the kind of cutoff point for sample size is 30 or more, and using a normal distribution would be okay. Less than 30, then we really need to use a t distribution. However, a lot of statisticians would just use a t distribution all the time and kind of disregard that caveat about sample size. And that's kind of where my mindset is. So now that we're at a point where you've learned about the student t distribution, my suggestion is to just use the student t distribution for all of these problems. So we're going to construct the 95 confidence interval here on the calculator. I'm going to show you how to do that. To find the correct command to do this, you press the stat key, and then it's under the tests menu. And notice right here, number 8, we have a z interval and we have a t interval. So we could use a z interval here. And maybe, I'm going to actually, since it's so easy on the calculator, I'm going to do it both ways. So I'm going to choose number 7. And notice it's interesting because right here it's asking for sigma. And this is one of the key difficulties with using a normal distribution or the z-interval technique, is that we need to know the population standard deviation. Well, we don't know that. And so we're going to fudge this, and this is a technique that statisticians use a lot of times. We're going to fudge it and just put the sample standard deviation in here. And there's a shortcut. I don't need to go back and remember it. I can go to vars and then down to statistics and choose S sub x. And the last data set I did the one var stats on, that's the sample standard deviation that will be saved automatically as S sub x. And you can see there it is. So the other thing I need to do is to paste in the list, the data, the list that I put the data in. And looking at the confidence interval, it's 95%, so I need to adjust that. The C level or confidence level is 95%. And then we select calculate. And the calculator goes through all the computations and prints out the interval. So the Z interval here would say that we're estimating the true mean lengths of these eggs to be somewhere between 22.03 and 22.57 millimeters. So I'm going to go back though, and I'm going to do another, I'm going to use, again, I'm going to calculate also a T interval. And I suspect that these intervals are going to be fairly close. So let's just redo this. Now, again, our input is data. I should have mentioned we can also enter the summary statistics. There are two options for how to create the interval. The list is the cuckoo list that I created. And notice there's no request for a population standard deviation. And that's one of the key things about the student's T distribution. You don't need a population value or a parameter value to calculate or to use the T distribution. The actual parameter is what we call degrees of freedom. And now it's just as simple as choosing calculate. And so here's the interval. It's about 22.02 to about 22.56. So it's almost the same, but notice it's a little bit wider. And that's what you get from the T interval. And that's because the T interval has those fatter tails, like I talk about in the video, which will create or cause the critical T value to be a little bit bigger than what the critical Z value would be. And all of those technical details aren't all that important. The key thing is to understand that when you use a T distribution to calculate a confidence interval, your interval is going to be a little bit wider than it would be for the Z, especially in the case of a small sample. The difference between the two intervals will be much, much more dramatic. So let's get back here to the interval. And this is the interval that I would report and use if I were doing the analysis. So I would say the interval is about between 22.0 and 22.6 millimeters. So let me just write that down. I already forgot what that other value was. Let me double check here. It's at 22.6. That's right. So part C asks, what does our interval in part B tell us about the mean length? Well, what it tells us is that, again, it's an estimate of the population parameter value. So when we think about the parameter value, the population mean, we're really thinking about all the possible lengths of cuckoo eggs, or all, and there could be, I don't know, thousands, tens of thousands, a million. I have no idea of how many cuckoo eggs this population may actually consist of. But however many there are, we assume that there's some unknown population mean length. And what this interval is giving us is a range of values that we're going to use to as our estimate. So we're going to say that we believe the true mean length of these eggs are between 22 and 22.6 millimeters. And we say in statistics we're 95% confident that we've captured that true mean value. The important thing to keep in mind, though, is that in statistics there are no absolutes. And so there's a 5% probability that we've missed that parameter value and it's on one side of the interval or another. So in other words, it could be or like say 21.5 or 23. We don't know that, but 95% of the intervals that we would calculate in this way would capture the mean. And that's what we mean by the 95% confidence. And of course, if we lower that confidence level, the interval gets wider, or I'm sorry, the interval gets narrower if we lower the confidence interval. If we raise the confidence level, the interval gets wider. Now let's talk a little bit also about part D. The question is there evidence that the mean length differs from 23 millimeters? And for this example, yes, there is. And the reason is because 23 millimeters, I keep wanting to say milliliters, but I mean millimeters. So if I said milliliters, please forgive me. So that's what we're speculating on. Is this the true population mean length? And since this is outside of the interval estimate, we would say, yeah, we have evidence that the true mean length differs from 23. It's looking like it's less than 23. And that would be the basic explanation that I would be looking for in the final. Now I have a practice problem for you to try. So go ahead and pause the video and try this problem. So again, you have data you need to enter into a list using the same techniques that we used. I don't ask you in this practice problem to calculate the summary statistics. Generally, I think we mostly look at the QQ plot and or a histogram to see whether or not the normal distribution assumption is reasonable. I'm not going to show you the answers to this problem in this particular video, but I would like you to message me any questions you have about this problem. If you're confused about anything, if you can't get the calculator to work correctly, please send me a message in Canvas, and I'd be really happy to give you more explanation, or also the answers if you're so inclined to see those. Again, have a great day, and I'll see you next time.